Hi everyone. Today I'm going to discuss lecture 6 of the lecture series I uploaded in YouTube. And this is about sample problems for force resolution type 1, force resolution 2, force resolution 3, force resolution 4. And there is also another problem. It's about the applications of dot product and cross product. So for the first example, force resolution 1, for the 300 Newton force shown, resolve it into number 1, x and y components, number 2, x and y prime components, letter C, x prime and y components, and D, x prime and y prime components. So this is the figure, and we're going to resolve it first into x and y components. Since the 300 Newton force is directed up to the left, its x component is negative. It is equal to negative 300 times 3 over 5 because the slope is 3 horizontal, 4 vertical, so 5 hypotenuse. So 300 times negative 3 over 5, it is equal to negative 180 newtons. Then Fy is 300 times 4 over 5, so it is 240 newtons. Let's proceed to part B, x and y prime components. So let's consider the force and the x and y prime components. So this is the force, this is the line parallel to the x-axis and the line parallel to the y prime axis beginning with the tip of the force. Since Fx is this component in the negative x direction, so Fx is negative while Fy is in the same direction as y prime, so it is positive. Then let's call this angle theta. Then the angle between y prime axis and the 300 Newton force as alpha. From the figure, theta is arctan of 4 over 3. So it is equal to 53.13 degrees. While alpha, because the total angle here is 60 degrees, because this is 30, so 60 degrees minus 53.13 degrees. So alpha is 6.87 degrees. So isolating this as a triangle, and so that's alpha. This remaining angle, let's call that as beta. So we have here alpha equal to that, then theta 53.13, so beta is 180 degrees minus 53.13 degrees minus 6.87, so 120 degrees. Then let's apply the law of sines to solve for this component. So fx is expected negative, so negative fx as to sine of 6.87 equals fy prime as to sine 53.13 equals 300 as to sine of beta, which is 120 degrees. Solving for fx, it is negative 41.44 newtons. Fy prime equals 277.1 newtons. So another way of, or another method of solving fx and fy prime, we call this component method. So f is negative 180 plus 240 from this part A here. Then we imagine that we have two forces, one along x prime and one along x and one along y prime axis. So fx, then plus f, the component of the force along y prime along x axis is fy prime cosine of 120 degrees, because this total angle is 120 degrees, 90 plus 30. So fx plus fy prime cosine of 120 degrees equals the x component of the force, which is negative 180. So let's call that equation 1. So for the second equation, the y component of the force can be computed because the y component of the force along the x-axis is 0. So the y component of the force along the y prime axis is fy prime cosine of sine of 120, and it is equal to 240. So 0, there's no y component of the force along x, then plus Fy prime sine of 120 because the y prime axis makes an angle of 120 degrees with the positive x-axis, then equals the y component of the original force, which is 240. So Fy prime is 277.1 newtons. Then substitute this into equation 1, Fx plus 277.1 cosine 120 equals negative 180. Solving for Fx, it is equal to negative 41.45. So they are close. The discrepancy is due to rounding of values. Then let's proceed to part C, the x prime and y components. So we have, this is the x prime axis and the y axis. This is the force. Then these are the lines parallel to x prime and y axis. So again, fx prime or fx prime is negative. It is directed in the opposite direction. Fy is expected positive. Then the angle here is equal to 53.13 degrees plus 30 degrees. This is also 30 degrees. So 53.13 degrees plus 30 degrees is 83.13 degrees. Then this angle here is equal to this angle here, which is uh, 90 minus 54.13. So this angle is 60. So therefore this angle is 180 minus uh, 83.13 minus 60, or simply 90 minus 53.13, so 36.87. By the law of sines again, so fx prime is expected negative, so negative fx prime as to sine of 36.87 equals fy as to sine 83.13 equals 300 as to sine 60. Solving for fx prime, it is negative 207.8. Fy is 343.9 newtons. Then finally, with respect to the x prime and y prime components, so this is the x prime, y prime components, parallel to x prime, parallel to fy prime, and because x prime and y prime are perpendicular to each other, so this supposedly parallelogram reduces to a rectangle, and considering only half, then this is a right triangle. From the figure, fx prime is negative and it is equal to negative 300 cosine of this angle, which is 83.13, while fy prime is positive, it is 300 sine of 83.13. So fx prime is negative 35.89 and fy prime is 300 sine of 83.13, so it is positive 297.8 tons. So that's the example for the first example. Then in preparation to another solution, by this is called vector dot, this is dot product approach using vectors. So the unit vector for x prime, because it makes an angle of 30 degrees with a positive x-axis, is the x component of the unit vector is cosine 30 degrees I, then the y component is sine 30 degrees j. So in other words, the unit vector along the x prime axis is equal to this. So it is 0.5 square root of 3i plus 0.5 j. Then lambda y prime is uh, cosine of 120 degrees I plus sine 120 degrees j. So it is negative 0.5 I plus 0.5 square root of 3 j. So by that product, so the x prime component is equal to magnitude of force times cosine of theta between x prime and the force, or simply dot product. So f dot unit vector of x prime, if you expand that, that becomes f times 1 times cosine of the angle between them. So if you interpret F times cosine of the angle between them, that's the x prime component of the force. So if you compute negative 180 times 0.5 square root of 3 plus 240 times zero point 0.5, the result would be negative 35.89, while f dot lambda y prime is negative 180 times negative zero point 0.5, that's 90, then plus 240 times zero point 0.5 square root of 3, the answer would be 297.8. So that's the other solution. For the second problem, in three methods, find the components of the force vector given by F20I plus 12J kilonewtons in the direction U and V axis. So for the first approach, by the parallelogram or triangle law, so this is the given figure. The angle that Q makes with the positive x-axis is 60 degrees. Then the y-axis, the v-axis makes an angle of 150 degrees counterclockwise from the x-axis, or 30 degrees with the negative x-axis. So for the first method, we have this triangle law. So call that Fu negative Fv, because Fv is expected negative because that's the positive direction. Call this theta F. Tangent theta F is 12 over 20. This angle is 30 degrees from the given figure above. So tangent of theta F is 12 over 20. So theta F is 30.96 degrees. Then the total angle here is 30.96 theta F plus 30. Since this is a right triangle, the magnitude of F is square root of 20 square plus 12 square. So F is equal to 23.32 kilonewtons. So therefore, negative Fv is 23.32 cosine of 30.96 plus 30, while Fu is 23.32. It is opposite. This is also equal to Fu, so sine of 30.96 plus 30. So Fu is 20.39 kilonewtons. Then Fv is negative Fv is 23.32 cosine of 30.96 plus 30. So Fv is negative 11.32 kilonewtons. Then for the second solution, we call this by net component method. So imagine that there are two forces, Fu and Fv. The angle that Fv makes with the positive x-axis is 150 degrees. So the component of Fu along x is Fu cosine of 60. So Fx is Fu cosine of 60 plus Fv cosine of 150. So simplifying, and Fx is equal to 20, positive 20. So 0.5 Fu minus 0.5 square root of 3 of Fv. So call that equation 1. Likewise, Fy is 12, and Fu and Fv are both positive. So the component of Fu along y is Fu sine 60, while the component of V along y is Fv sine of 150 degrees. Simplifying, 12 Fy is 12.5 square root of 3 Fu plus 0.5 of Fv, equation 2. So solving these two equations simultaneously by elimination or by substitution, we obtained the following values. So Fu is 20.39 kilonewtons and Fv is negative 11.32 kilonewtons. Then for solution number 3, by dot product, so lambda u, unit vector of u is cosine 60 degrees I plus I sine 60 plus sine 60 degrees j, while lambda v is cosine 150 degrees I plus sine 150 degrees j. So simplifying lambda u, it is 0.5 of I plus 0.5 square root of 3j. So lambda of v is cosine 150 degrees I plus sine 150 degrees j. Simplifying, that's negative 0.5 square root of 3i plus 0.5j. So obtaining the dot product of f and u, so it is f times f dot f f dot lambda of u is equal to f times 1 times cosine of the angle between f and fu. So f times cosine of this angle is actually fu. So fu therefore is simply the dot product of f and lambda u. So f dot lambda u is equal to this f times magnitude of lambda u, which is 1 cosine of theta u. So this is theta u. Then f times cosine theta u is fu. So we simply obtain the dot product of f and lambda u. And therefore it is equal to 20 times 0.5 plus 12 times 0.5 square root of 3. So remember that that product of two vectors is simply the sum of product of corresponding components. So it is 10 plus 12 times 0.5 is 6 square root of 3. So in decimal, FU is 20.39. While FB is the dot product of F and the lambda of the V axis. So 20i plus 12j times negative 0.5 square root of 3i plus 0.5j. So FV is equal to 20 times negative 0.5 square root of 3 is negative 10 square root of 3 plus 12 times 0.5, which is 6. So simplifying, FV is negative 11.32 kilonewtons. So those are the three different methods of solution. Sample 6.3, determine the value of the scalar M if the following forces lie on the same plane. So we have three forces that lie on the same plane, F, P, and Q. So M is a component, C component of the force P. So since the three forces lie on a single plane, if we obtain the cross product between two vectors, then we can define another vector, which is a force perpendicular to the planes of the three vectors. And since that vector is perpendicular to a force P, then their dot product would be 0. So our plan is to obtain cross product between F and Q first to define a vector or a force which is perpendicular to the plane of the three. So we'll have first F cross Q. So we can define a force which is perpendicular to the plane of the three forces. Then F cross Q is components of F, then components of Q, then the unit vectors, then copy the first two column elements, then apply like evaluating the determinant of a 3 by 3 matrix. So we have negative 7, negative 1 times 7i minus 46 times 2. So negative 7 minus 92i. For j, we have 2 times 16, 32 minus 14j. Then k, 2 times 46, 92 minus negative 16, so plus 16 quantity k. Simplifying, it is negative 99i plus 18j plus 108k unit newtons. Then we obtain the dot product of this vector with p, and we set the result to 0 because they are perpendicular. So f cross q dot p is dot product or of perpendicular vectors. So that's why it is 0. So f cross q equal dot p equals sum of product of corresponding components. So 6 times negative 99 plus 3 times 18 plus n times 108 equals 0. So solving for m, m is 5 newtons. So it should also be in newtons. And example 6.4, let's call this force resolution 3 examples. Resolve the 400 Newton force shown below into U and V components using the dot product. So we have here the 400 Newton force. So let's apply the dot product here. So let's define first the unit vector of U, which is 12 over, since this is 13, 12 over 13i minus 5 over 13j. So F is negative 400 cosine of 55 because it is leftward, then positive 400 sine of 55j. So negative 229.4i plus 327.7j newtons. The unit vector u or lambda u is 12 over 13i minus 5 over 13j. Then the unit vector v is 5 over 13i plus 12 over 13j. So obtaining the dot product, or remember that the dot product of f and the unit vector u is automatic fu. So fu is negative 229.4 times 12 over 13. So that's negative 229.4i plus 327.7j. This is f. Then dot of lambda of u. So that would be equal to negative 337.8. So that's negative 229.4 times 12 over 13 plus 327.7 times negative 5 over 13. We get negative 337.8. Then FB is equal to F dot of lambda of V. So the result is FV. So negative 229.4 times 5 over 13 plus 327.7 times 12 over 13, and that is equal to 214.3 newtons. Last example, resolve the force F 35I plus 55J plus 25K newtons into two components, one perpendicular to the plane ABC. Let's call that Fn, and the other lying in the plane ABC. So we call that F sub T, the tangential component. So that's the given figure. So before we can express F into components perpendicular and tangential to the plane ABC, we must define a vector perpendicular to ABC. That vector should be almost in the same direction as F. So we should cross vector AC with AB. From the figure, vector AC is equal to 6i minus 3k, while vector AB is 4j minus 3k. So it is backward 3, then upward 4. So that's why it's 4j minus 3k. Let's obtain the cross product of AC and AB first to define a vector perpendicular to the plane. So 6i minus 3k cross 4j minus 3k. So we have 6 times 4, 24, I cross j. Then negative 18, I cross k. Then negative 12, k cross j. Then 9, k cross k is 0. So that's why it's 0 there. I cross j is equal to positive k, while I cross j is positive k. I cross k is negative j. This is negative j, while k cross j is equal to negative I. So this is negative I. So we have positive k, negative j, then negative I. So simplifying, AC cross AB is 12i plus 18j plus 24k. So this is the vector perpendicular to the plane of ABC. So we obtain the unit vector of this vector because we only need the unit vector. Lambda is 12i plus 18j plus 24k divided by its magnitude, 12 square plus 18 square plus 24 square. So lambda is equal to, in decimal form. So this is the lambda. This is the angle between F and theta. Then we can compute the component of force perpendicular to the plane, which is F dot of theta, F cosine theta, or Fn is F cosine theta, or F, we dot the force F with lambda. Then Ft is perpendicular to Fn, so we use the relationship vector Ft plus vector Fn equals vector F. Then we can solve for Ft. So lambda in decimal is 0.3714i plus 0.5571j plus 0.7427k. So f dot lambda is equal to f times 1 cosine of theta equals fn. So Fn is 35 times 0.3714 plus 55 times 0.5571 plus 25 C component times C component of unit vector 0.7428. So Fn is 62.21 newtons. Then Fn is equal to 62.21 times in vector form. So magnitude of Fn times the unit vector of that perpendicular to the plane. So we get Fn in vector form 23.1i plus 34.66j plus 46.21k. Then Ft plus Fn equals F, because Ft and Fn are perpendicular. So we have Ft plus Fn equals F, substituting the value of F, then minus the value of Fn, then we can solve Ft. So Ft therefore is 35 minus 23.1 plus 55i, 35 minus 23.1, quantity I, plus 55 minus 34.66j plus 25 minus 46.21k. So solving for Ft, it is 11.9i plus 20.34j minus 21.21k newtons. So I hope that we will practice solving problems about force resolution on 2D, and this is one application in 3D. So thank you for watching, and don't forget to subscribe. See you see you then for the next lecture series.